and what the technology is and when it will be used. I'll just let everybody join. We're expecting quite a few on this call. As the previous discussion groups, I'd be very grateful if you could add your company or organization name to your label on your little Zoom window. It makes it much easier to contextualize everyone's comments. I also would suggest, if you can, and if you're willing to be video on. Again, it just makes it a bit more personable when we're having the conversations. So if you would be video on, that would be terrific. But please do add your organization name, just to give everything a bit of context. Okay, I see we're now got 30 people on the call. Great. Okay, as I said, this is a session where we're going to be looking at chemical recycling, and it's the scope as a solution, and the technology that's being developed, and where and when it can be used, and also thinking of terms of scale. Always very important to think of how we can get everything up to scale. As I said, I would, if you can be on video, please do put it on video. A few final bits of housekeeping. We are recording the session as previous sessions. If you want to make points, and I hope you will, the whole point of these discussion groups is that everybody gets involved in the discussion as much as they can. If you want to make a point, please either use the chat box at the bottom of the screen, or put your hand up using the raise hand function in the reactions button. So you do that. If you do that, then I will certainly bring you in. It would be great if you're happy to make your questions yourself, that'd be super. I'm very happy to read them out from the chat box as well. All right, let's get going. Joining me today, I'm delighted to say we have Edwin Key, who's from HKRITA, Dhruv Agarwal, I apologize if I mangled that slightly, from Contour Brands, and Cindy Rhodes from Born Again Technologies. Welcome to you all. Okay, Cindy, perhaps you can go first. Give us maybe a sentence of context-setting introduction, and then explain to us a bit about Born Again's processes and what you're trying to achieve. Cindy.
Great, thanks, Ian. Good to see everyone today. Yeah, my name's Cindy Rhodes from Born Again Technologies. I founded the company back in 2005, and since 2012, we have been in development of a polymer recycling technology for non-reusable textiles. And just to give you a flavor of how the process works, we can take in pure polyester, polycotton, and polycellulosic blends, which together, these represent quite a significant proportion of textiles which are out there. And the process is able to separate, decontaminate, and extract polyester and cellulose from cotton to produce two outputs. And those two end products are PET chips and a cellulosic pulp. Both of these will then go back into the supply chain to become new fiber and textiles all over again. And we have 3 development targets for the industrial process: that the process itself will produce cost competitive outputs at a virgin equivalent quality, and via a production process which is environmentally friendly. And then our wider ambition or target is really for this process to play a significant role in enabling the industry to start replacing the use of virgin resources with circular resources. And then to give you an idea of where we're at in development, so we have a pilot plant which is up and running in Redcar in the north of England, where we are carrying out a number of trials to optimize the processing steps, to optimize the outputs, and all of these developments are helping to inform the next phase of development, which is designing the demonstration plant. And that'll be our focus in 2022. And then from there, once that demo plant is up and running, that will inform the licensing package. And that's what our business model is based on, is licensing the technology to plant operators around the world. So that's the tech, that's where we're at. I wanted to make a comment about timeline to circularity, given that that's in the title of this session, where is the tech and when will it be widely used? And I think, it's really important to say that, the industry is still in the very early days of circularity, with less than 1% of new textiles being made from existing textiles. So really going from replacing the 60 to 70 million tons of virgin raw materials when we talk about cotton and polyester, going from 1% to 80, 90, 100% is an epic undertaking. And it's going to take a huge amount of time, investment, evolution of infrastructure, among other things. And just to give you a bit of context on that, we have a goal of licensing 40 plants by 2040. Now, if each of those plants are operating at 50,000 tons each, once we reach 40 plants, do the maths, that's still only 2 million tons. And so, you can imagine it's going to take a portfolio of solutions, from mechanical recycling to chemical recycling, to really deal with the issue. And I think you could call it a problem, the problem of textile waste, but I'd also point to it as a huge opportunity in terms of moving to circular production and output. There's room for multiple solutions. We need as many as possible to be complementary to kind of get us to this end goal of circularity. We need many of them, and we need them fast.
Thanks, Cindy. Let's talk a little bit about your process. You say you mentioned you use pure polyester, polycotton, and there was one other, wasn't there, in your inputs, and your output is PET chips and cellulosic pulp. What's the cellulosic pulp?
So cellulosic pulp is the equivalent of dissolving wood pulp, which you would get from trees, to then go into viscose, lyocell, that sort of process.
Okay,
so
excellent.
Similar to, for those of you who are familiar with Renewcell, it's a similar output to what they're using.
Fine. So it could go into the production of viscose potentially.
Exactly.
And what are there any other waste products, any that can't be reused?
So, well, everything that goes in that's not polyester or cotton will come out as waste. So all the dyes, the finishes, any other contaminants. We can also take up to 10% other. So there can be nylon, wool, elastane, anything that goes in that's not polyester or cotton will come out as waste. So if we start talking about designing for circularity, in some ways the industry doesn't have to change the way they design to be able to go into our process. But if they do, it will mean a more efficient process. It'll mean a higher or more effective yield. So the less other stuff that goes in, the better yield that will come out in terms of outputs.
Immediately got a question from Ushi. How does your sorting process work? Is it automated? And what about zips and things like that?
Good question. So our kind of part in the whole supply chain, we work with the end of use textile supply chain. We're working with them today to communicate what our feedstock specification is, to communicate what kind of textiles we can take in. And we will rely on the existing end of use textile supply chain to do the sorting, the separation, into the different buckets for different feedstock specifications. So we will work with a company like SOEX to say, anything that is polyester, pure polyester, polycotton, and up to 10% other can go into our process. So we need that separated. We need these the collection in the sorting industry to start moving towards fiber sorting technologies, high volume separation, highly automated systems in the future, because the supply is going to be quite high. And then in terms of buttons and zips, absolutely, we need buttons, zips, any of the metals chopped off cut out because we can't take metal into the process. But yeah, that's a whole pre-processing step that we need to be working on together with the feedstock supply chain collectors and sorters to achieve this type of specification, and also working with the other technologies, because everyone will have some similar but also some different requirements for their feedstock.
Great, thank you, Cindy. Lots to talk about there, and loads of questions coming in already, which is super. We'll come back to some of them in a sec. I want to give our other panelists a chance to make some comments. Edwin, perhaps I can ask a similar question to Cindy. What technology are you developing that can take, and how can that take chemical recycling to scale? Edwin.
Thank you. So I run something called the Research Institute for Textile and Apparel. We're an applied research center, and we do research for the textile and apparel industry. We're not for profit. And we have, and sustainability is one of our 3 big research domains. And in the sustainability area, we have worked on recycling for a couple of years. And we're not very selective about in terms of the technologies that we are interested in. So we have worked on highly automated mechanical recycling. We are currently working on biological methods of recycling using enzymes and fermentations. And in the area of chemical recycling, we sort of failed. I think we tried to work with chemical recycling, and we found that we were not successful in dealing with a lot of the waste streams that we were creating. So we started to take chemistry out of chemical recycling processes. And so one of our outputs is a new, what we call a hydrothermal system that we have built a pre-industrial scale system, and we're currently building an industrial scale system. And this uses mostly heat and pressure to separate materials. And currently we use this system to deal with things that are cellulosic and synthetic materials in nature. The polyester material, the synthetic materials, come out in staple fiber. So those we have just been twisting together, and depending on the quality of the feedstock, blending in a percent of virgin material and turning those back into yarns and fibers. So it's a very short process, about 90 minutes for the process, and then it goes straight a garment to fiber, and it can be used again as raw material for new apparel. Cellulosic material comes out in powder form, and currently we have three and potentially we think there are more outputs, useful outputs that we have been developing with the cellulosic material. We have been using it as a raw material for a new type of viscose that we are currently functionalizing, a new viscose yarn, and we are adding thermal management and moisture management properties into that, and we expect that work to continue this year. That work we're doing with a Japanese developer, and we expect that work to complete to go on this year. We've also, with the cellulosic material, functionalized it into a super absorbent polymer, which we have been using and we've used in the growing of cotton. And so we conducted a small-scale experiment last year, and in the growing of cotton, and we found cotton to grow using this super absorbent polymer that it comes from the cellulosic material. That the polymer absorbs and releases about 30 times its weight in moisture, and repeats the process over and over again. So we used it. We put it in the root structure of cotton plants, and cotton in our small-scale experiment grows without irrigation, and it grows 20% faster. It yields more per acre, and it has longer fiber. So it's generally a healthier plant. The large-scale experiment will be conducted this season in the next 2 months, and the goal there is to develop a is to be able to experiment to see if we can grow cotton in more marginal lands, to grow cotton without irrigation, and to grow higher quality cotton and improve the output of cotton to the benefit of cotton farmers. The third and final material that we have developed from the cellulosic side of the output is a PFC-free DWR surface treatment, which we have just completed. Well, about to complete, and that we think we're also very excited about. It works quite well, and we are looking at improving on it a little bit more before we finish the work. So a lot of interesting high-value output so far. The disadvantage to us so far in our hydrothermal chemical experiments have been that the process destroys protein-based materials. So we are currently in the process of building a front end to the hydrothermal treatment, where we're using a triboelectric process to separate the disentangled material into protein, cellulose, and synthetic materials, and that's an ongoing work. I'll stop here. I probably told you more than you wanted to hear.
Speaking for myself, it's fascinating. Thank you very much indeed. What's the potential price point comparison of what you're producing at the end compared to virgin material? I mean, I guess it's a bit of a hypothetical question, but you're talking about having outputs which can be used to for viscose or similar yarns, similar materials, fabrics. What's the kind of potential price point comparison, do you think, in terms of using your process versus more conventional source material?
Well, you can imagine, first of all, it's a great question, and it's one thing that we're trying to find a good answer to as well. In terms of the footprint of the process, because we only use heat and pressure and almost no chemicals. All we're trying to do is to control the pH, and the process is any of the liquor we use over and over again. There is almost no discharge for this. So it's a very light footprint, and it's a 90-minute process as opposed to these much longer processes if you're going from virgin. We are blending 60-70% recycled content. Nothing that we've done so far is not chief value recycled content. And so depending on the quality of the feedstock, we can get fairly high recycled content, but still we're blending in virgin content just to strengthen improve the tenacity of the material. We are building a industrial. We've been contracted to build an industrial scale, a small industrial scale system with about 1.5 tons to 2 tons a day output. And without a lot of deep understanding about the cellulosic side, because we're still working on all the cellulosic output, on the polyester side, if we can hit like a 2-shift or 2.5 shift, we can work this 2.5 shift almost continuously, and get the efficiency and the reliability out of it. It is now currently almost on par with virgin polyester. A slight upcharge, but we've not taken into account the cellulosic materials and what value they are. We can generate from that, but we are very confident we can get to price comparable and performance comparable. I want to add that the advantage of the hydrothermal system that we've developed is that it's quite a benign system. So the performance, the hand feel of the input material and the output material are on the polyester side is identical. There's no detectable deterioration to performance. So we're quite excited about that.
Thank you. Just to pick up the question we had earlier about other things, things like zips, other buttons, those sort of things. Do they just come out the other end of the process? Can you put that into your process and they disappear at the end of the process, or do they have to be removed before going through the process?
We still have to figure out how to remove those, and we are. So that's the bad news. So you still have to do some processing of it. The good news is that it is quite a non-selective process. So in terms of the composition of the batch of material you're processing, it doesn't really care. It will just separate materials and process materials, regardless of the cellulose to synthetic content, if you will. There are materials, for instance, down jackets and raincoats and rubberized materials that we can't process currently in the system. But by and large, it is quite non-selective about its feedstock.
Okay. Thanks very much. Well, that's fascinating stuff from you both. Thank you very much indeed. Let me turn to Drew now. Can you just reflect a little on what you've heard from Cindy and Edwin, and from the perspective of your brands? I do give us a sentence of context about your introduction. What is useful for you in terms of recycled fibers, and what would you need to introduce more and more recycled material into your garments?
Thanks, Ian. Thank you very much, and thanks to Cindy and Edwin for explaining their process. That's very, very important to know how their process works. Recycling is a big thing for sure, and we, as a human being, are looking to maintain the resources which we have taken out from our planet and see how long we can keep them working for us as long as possible. We do not want to send them to the landfill. We don't want to incinerate those things. So recycling is the best thing to do. So from that angle, I really appreciate what Cindy and Edwin are doing. Both have taken a different approach. They have a different way of working. And ultimately, as a consumer, we are looking for a product which is equivalent to what we have been buying. We, as a consumer, want to have a product which is similar in hand feel, similar in performance, similar in coloration, and similar in price eventually. And that could be the thing we are looking for. So as a brand, we are basically feeding to our consumer, and consumer is basically looking for these kind of things. So from that angle, I really appreciate what these guys are doing. And but what I also heard today is that, and knowing this industry quite a lot, the chemical recycling, whether you call it a hydrothermal or through a chemical process, it's taken a lot of time to really scale up. When Cindy is talking about starting something in 2005 to 2012, and now in 2021, it's still in an early phase. Things will take time, and she is pretty clear on that. So we are not looking to have these things coming quickly. She's talking about licensing this, licensing to that is another thing. Who is going to invest in these technologies? We have many paper companies who are looking to invest and diversify in fiber world, utilizing these kind of raw materials. And there are many other players, but I think it will take some time. From that angle, we as a brand are always looking for the right raw material and an efficient supply chain. We do not want a supply chain which is erratic. So from that angle, also pricing is the most important thing. Ultimately, consumer is definitely looking to pay, but we have to have a certain limit in terms of what we want to pay. So scale, efficiency, quality, performance, all these things are very, very important from a brand standpoint.
Okay, so ultimately, you would go and think about using these sort of fibers when the price is right. But again, it comes back to the price has to be right. What then is the, if any, would be your concerns relating to consumer reaction? Do you think consumers would have negative reaction potentially to if they knew that it was recycled content in their garments, or do they in fact are they looking for this? Do you have any sense from your customers as to what they would prefer?
No, I haven't done any kind of a consumer study, but I have been reading a lot of consumer studies on this area. There is always a segment of consumer who is very much willing to look at these kind of materials. When we are saying recycling, I want to be very clear, and I think I saw some comments in the chat box also. Materials with the chemical recycling, it's a recycling process, but the ultimate output of these recycling process is kind of a new fiber. It's not like a chopped fiber which is coming out of a mechanical recycling process. Out of this whole process, when you take these feedstock of cellulosic materials or a polyester polymer, you are again further extruding it out into a new fiber. So that new fiber is pretty much equivalent to a virgin fiber. That's the expectation. That's what I'm saying. That's the expectation. And for a consumer, I think the main thing is that what is the feedstock? If the feedstock is an old textile, a feedstock is a byproduct of some other industry or agricultural waste, and which gives you a cellulose material, definitely that they will be willing to take as long as the performance is equivalent to a virgin fiber. I think from that angle, we should be okay. But what I'm telling you is what I've read in the consumer surveys. Done nothing from our side. We have done any kind of a consumer study on this topic yet.
That's a good point on the fibers, isn't it? Because as I understand it, and this again reflects the comment in the comment box, when you're doing physical recycling, physical sorting, potentially the fibers can be of a lower quality just because of the nature of the process. Whereas, as you say, from chemical recycling, what you're getting is ultimately the same level of quality at the end of the process. So it is for you. There's a kind of potential in terms of quality of product. It's a level playing field. Pricing, of course, then comes into play. Interesting. Thanks very much indeed. So thank you to your questions. A load of questions. So I'd like to actually, if I may, suggest that you make your questions yourself if you're happy to do so. I want to go back to a question that came in that it was actually answered by Cindy on the chat, but I just want to be interested to see if we can make just have the answer on camera as well. So it was Anton first. Anton, do you want to make your point? Anton, I guess you don't want to make your point. Well, I'll make it for you then. So Anton asked about...
Sorry about that. I had technical difficulties.
Anton, over to you.
Hi. Basically, I asked Cindy in the chat whether decolor... You said that the dyes come out as essentially a waste product. And I was wondering, as a result, are decolored inputs preferable to colored inputs? Does it make the process easier? Does it avoid the sorting process? And sort of, does it just add fewer contaminants into the chemical recycling process generally? Although I should say Cindy did actually write an answer to that in the chat for me.
And
Thank you, Cindy.
My cat joined to answer that question. Yeah, no, I think, we developed this process to deal with textiles the way they are produced and made today. And, with the intent that, when we started out in 2012, no one was talking about circularity. No one was talking about changing the way they design. So this process had to be robust enough to be able to deal with textiles as they are today. And as I said earlier, potentially there are ways to optimize it. The less crap, sorry, the language there, but the less that goes in, the less waste we have on the other side. So I think there's room for innovation around that. But yeah, it's not a problem. It's completely designed to deal with the dye stripping of both the polyester and the cotton.
Thanks, Cindy. Steve Bethel has made a point. He's raised his hand. So I'll bring Stephen Bethel in. Stephen.
Hey, thanks, Cindy. Nice to see you again. I sort of bring up this sort of, point about cost, right? Because it always seems to come to the point. I think, and it's not a question, but just a conversation. When we look at, the amount of effort that has to go into the sorting, Cindy brought up, how do you triage the product? And then Edwin brought up the point that we've got to remove the trims, all of which we as a company are doing. And you look at the cost of the pure input, we're not going to be cheaper than virgin. So I feel like I want to just point out that the emperor is not wearing chemical clothes, and the reality is that until we put a cost on carbon, or a cost on the cost of raising virgin product, which is really cheap, will this ever work, at scale? And the reality is, though, that some brands, like the work we're doing with RenewCell, they're proving that it is doable at scale. We're there, but it's not cheap. So we got to get away from this mindset that we're doing this because we're trying to reduce costs, because that's not going to be the thing.
Yeah, I'd like to respond to that. And it's,
Sure.
Yeah. So Stephen, I think it's a big question. And there's a couple of layers to that one. And I would say just starting from a cost perspective in terms of processing, when we look at our cost model, we've allocated a price to pay for incoming feedstock that has been sorted, prepped, ready to come into the process. And then the process itself has been designed to be low cost, so that with those two components in mind, that our future plant operators will have the flexibility to then compete on price with whether it's virgin resources, whether it's other circular recycling technologies. But we believe from the work that we've done with the end-of-use textile supply chain, looking at costs today of collection, of sorting, and that sort of thing, that we will be able to produce in terms of output, the actual overall cost, a price that is competitive. Now, the market will decide what the value of this is further down the line, as demand for end-of-use textiles increases, and there's all sorts of market levers at play there. But I think in terms of the basic costs and allocating enough for feedstock inputs and a low-cost process, that's going to give the flexibility for output prices to be competitive. But your other point there about measuring the other impacts, and incorporating those into what we pay for textiles, I think that's also set to change over the coming years. It depends what we value, what we want to put a price on, and what we include when we talk of cost. And that's something that the industry, it feels like there's a shift happening on that front. Where that will be in a couple of years, I don't know.
Thank you very much indeed. I want to turn to Tara Luckman from Cotton Council. Tara, do you want to make your point?
Thank you. And I'm rereading my question in the chat and thought maybe it's come across more facetious than it was intended. My question is really about if brands are kind of quite hot on trying to design for circularity at the moment, where are we in terms of prioritising what we should be designing out, fibre blends that we should be designing out, versus dealing with those fibre blends at end of life? And are we in a sort of medium time frame of having to deal with the symptoms of the waste versus actually preventing that waste problem in the first place?
Who'd like to have a go at answering that?
Yeah,
Edwin.
Let me take it.
Okay, Drew. Okay, quickly. Yep, thank you.
It's a very good question. I think one important thing which we are finding is that more and more folks are looking from the angle of monocomponent. So when you're talking about polyester cotton or nylon cotton or something like that, more and more folks are looking for how can we make it simpler for recycling, end of life aspect. So can we increase or make it like 99 or 100% cotton, or 99, 100% polyester or nylon? And we are seeing similar kind of things in some of the other cases also. So that is one trend which we are seeing, where we are looking for a reduction in the blends and trying to go to the monocomponents. That's one thing which I would just say, the trend we are seeing right now.
Yeah. I think it's a great question, and I think there are a couple of things to consider here. I think first of all, it's not like that there are not thoughtful or evil designers out there who are intentionally trying to make these use these materials that are hard to reuse. I think what we lack here is some design tools that help people who design at that point of decision making to understand the consequences of their material and construction selection. So that is actually is one of the things that we are working on, which is if you use material A in this way, here is what you're doing. Here's the carbon footprint, and here is an alternative that might actually be lighter touch in terms of its carbon footprint. So there is that piece. I think also the other end of the supply chain, there probably are opportunities to build tools to help consumers make decisions at the point of purchase about what they are consuming. So I think that would be one approach. I think the other approach, I think it was Stephen made that point either in the chat or in his remarks just now, which is that you have to price these things properly, right? That you're buying not only the product, but also what you're going to do with that product at the end of its life. So the easier and the more flexible and the more valuable it is, the less it should cost. But for things that are very difficult to reprocess, there should be an additional price that should be paid somewhere along the way. Can I also take the opportunity to address the question of waste as well?
Sure.
I think there are actually wastes up and down the entire supply chain. There, at most garment factories have 10 to 15% cutting waste. This is material that is just left over on the floor after they cut their patterns out. Then there are things that don't get sold in the store. They're wrong color, wrong size, wrong style. And those are also waste. And then there's post-consumer waste. I think there are different strategies that we need to adopt to address all of these wastes. And so in the factory, you have a lot of the same material, known construction, known content, same color. There are strategies that we need to adopt to deal with those. The things that don't get sold at the end of the season have not been used, have not been abraded at good quality. There's a strategy. And then post-consumer waste is another strategy. I think we need to look at technology and look at the opportunities in all of these different waste streams.
Thank you very much. I want to bring Cindy, if I may, I want to bring in another question. Anna Graham, would you like to give your question? Okay, well, if I may, I'll make it for you. Just in the interest of time. So it's really for Cindy. And Anna asked about the quality of the efficiency of the chemical recycling process and the level of feedstock. What level of feedstock does your and waste materials does the process need to make the output product economically viable? Cindy, quite a complex question, but if you could answer it briefly as we're getting close to where time is again running away from us. Cindy.
Yeah, I guess I'm not quite sure what you mean by the efficiency of the chemical recycling process. Do you mean how much input comes out as output? Pretty much all polyester and cotton that goes in comes out as outputs. And the level of feedstock. So in our feedstock specification, we say no more than 10% other, so that the yield is 90% or higher.
Okay, thanks very much indeed. I'd like to bring Anurag Gupta. Would you like to make your question? I think it's an interesting question, which comes back to, again, looking at cost. Anurag. Hi.
So I'm from India, and we are making recycled yarn. I've been trying to push this idea on a lot of forums that we are talking of a lot of legislations for recycling. And I feel that the basic challenge that comes in recycling is the mixture. Just now, Cindy was saying, 10% no other. So if we can somehow bring governments to increase taxation on polymaterials, and where there's a monomaterial, 100% cotton or 100% polyester, taxes can come down to a very lower level, which means brands will try to push monomaterials. Governments will have it, the recyclers will, it will be very easy for recyclers to recycle the materials. And I think a large portion, I mean, obviously designers would want to use multiple materials and all those things will stay. But we could probably have 20% of or 30% of garments which are made from monomaterials. And that portion it would be very easy to recycle, whether it is chemical recycling, whether it is mechanical recycling. So I've been trying to propound this idea for a long time that when people who are there to influence governments, if they can influence them for variable taxation, if we can come up with there's an idea for the innovation forum also, if you can propound a ease of recycling index. I mean, you propound that whether the material, how easy it is to recycle it. It is monomaterial, it doesn't have metal. So all these things, how, and sustainability index, recycling index. And then governments base their taxation on textiles based on the ease of recycling index.
Great, thanks very much indeed.
This will automatically push businesses in this direction.
Thank you very much indeed. Great question, very, very well put. Dhruv, do you want to have a think about that one? And I mean, again, this again affects the price point, because you talked before about price was important for you in terms of feedstock. So if there's a taxation element in there, or if even including, to go back to Stephen Bethel's point around carbon's pricing, is that the sort of level playing field that could help introduce more recycled content for you?
I think
yes, that is a utopian situation.
Anurag, thank you, Anurag. I'd like to put the point to Dhruv now. Thank you.
Okay. No, thank you, Ian. It's a good question. Just from the costing standpoint, I'm not saying that we want a lower price than virgin. They're saying it should be equivalent to a virgin. We never said that we want to lower than, and that is not something anybody should be talking about. Now, completely understand that there are so many challenges in collecting, sorting all these materials in all aspects, as well as the new technology. Definitely at the start of this process, there will be always challenges and the cost will be high, but as the economies of scale come in, prices should come down. As Cindy said, market will determine what the price will be. The points which Anurag is putting, I think that is already in one form applied in the polymer and plastic industry. We are seeing more and more legislations coming where the governments are putting a kind of a taxation to the polymer companies to ensure that any new virgin material has a certain higher aspect of cost, because they're putting a taxation. So these kind of things are important. I agree with him on some of these things. The question is, how are we going to do it? How are we going to standardize across the world? And those kind of things we discuss. But somewhere something has to be done to ensure that this thing can be scaled up efficiently. And if we don't have a standardized global way of collecting and sorting and as well as taxation, it will never work out. That would be my answer.
Thanks very much indeed. I would like to bring in as a final question. I think it's an excellent one to finish off. Will be Felicia Tang. Would you like to make your question, Felicia? Okay, I will make it. So Felicia's question is, what's the number one obstacle to scaling in your view? Is it high cost? Is it technical readiness, insufficient feedstock, lack of investments in innovation, or anything else? And I'd like each of our panelists to answer that, and thinking for the future. I will give you each a minute to answer that, because we're getting close to the end of the time. So Edwin, do you want to go first on that? Number one obstacle to scale.
Yeah, it really isn't a technical problem. It's more of a business case problem, which we've heard about already. But I think even more so, it's a logistics challenge. It is trying to get toothpaste back into the to the tube once it's been squeezed out. So we have to build a reverse logistics capability so that we can collect and process these materials once they're out in the marketplace.
Great. Well, thank you very much. You didn't even take your minute. Thank you. Dhruv, do you want to go answer that? For you, the obstacle to scale?
No, it's basically the availability of this material. As we are in very early stages of this chemical recycling, we have a couple of players who are trying to scale up. Cindy mentioned some of them. These are still very early. There's a kind of an embargo in terms of how much material you can buy. There's a great demand right now. So, but the challenge is that it's not available, and that is what we are looking for, is when would this be available at the scale level. And more investment is needed, but then completely understand what Edwin is saying and what Cindy is saying is there's still to be done from the angle of logistics of collecting and sorting, and that is what we need to think about. And secondly, where are we going to be putting these manufacturing plants? Is it going to be closer to the markets, or is it going to be closer to the manufacturing areas where most of the garments are made? And the whole aspect of which waste are we going to collect? Is it going to be industrial, post-consumer? All those things have to be taken into account. So for us, the scale is very, very important, and the efficiency of that process to get the right material at the right performance and the right quality, all that matters. So as we're still looking for it, we're still rooting for all of you and all your success.
Thank you very much indeed. Cindy, then, same question to you. What part for you is the number one obstacle to scale?
Yeah, thank you. So it's definitely not the tech, other than that it takes time to scale. So it's less of an obstacle, but it's more of a requirement. We need time. The big obstacle will be, and we talked a bit here about where the plants will be. We very much envisage our plants to be in high consumption regions in North America, in Europe, where legislation in Europe is gearing up to aggregate textiles, to put legislation around end-of-use textiles to make it more incentivized for collection. And, there's so much happening in that space with groups like Accelerating Circularity. We've been talking about it for years in Europe. There's also huge opportunity in the manufacturing countries as well with the post-industrial textile waste. So it depends whether we go for the low-hanging fruit of manufacturing waste or end-of-use post-consumer textiles. But it very much, for us, it makes sense to build those plants close to the source of collection. And the biggest obstacle is the way textiles are collected and sorted today and where they're sorted. I think that's the biggest area for innovation and infrastructure evolution that needs to happen to be able to supply high volume production plants in the future.
And is that what you think you will see? Is that this kind of next stage, you think? That's the next step for you?
I think it's happening already. We see a lot of it happening in the UK. We're all talking to each other. As soon as we build these plants, one plant, you're going to see everything shift around collection. But it really needs to look different than it is today, in that it needs to be highly mechanized sorting facilities. I mean, it's going to be a combination of things. Stephen has loads of experience of his sorting processes. It's going to be a combination of all of these things. But until we see these plants up and running, RenewCell is starting to shift the dial now to show the industry what's going to be required. But when we start seeing multiple plants, it's really going to be a massive evolution, and we need to be working together to build that new supply chain to provide the source for these plants. Great.
Well, thank you very much indeed. Thanks to all the panel, to Cindy and to Dhruv and to Edwin. It's been fascinating discussion, and thanks to everyone else for being willing to come on and to make your questions as well. It's been a really interesting session and a great discussion, and I hope worthwhile for everybody. We are coming to the close of this session. We're back in 10 minutes, where we will have another 3 of these discussion groups for you. We will have a session looking at empowering women throughout the supply chain, led by Kate Larson. We have a session on addressing the gaps in sustainability and why fashion brands need more data. I'm actually not sure they do need more data, but I'll be discussing that with Sandra Roos and Angie Feeling, and also looking at science-based targets for water with led by my colleague Toby Webb. So it's back at 2 o'clock UK time in 10 minutes. Thank you very much indeed, and it's been a great session. All the best.